Let us prove that square root of 2 is irrational, and let us do it by contradiction. So this is one of the classic contradiction proofs. So to prove that something is irrational, so first of all, we need to know what the definition is. So, and we've made this point before. You cannot prove something if you do not know the definitions. It's just impossible because you need to use them in the proof. So let's look at that. So what are rational and irrational numbers, right? So a real number is rational if it can be written as a fraction m over n, where m and n are integers and n is different than 0. So of course, for example, r equal to half is a rational number because you can write it as a division of two integers with the bottom one different than 0, right? Also, things like 3/4 and so on. Now, when a number cannot be written that way, it'll be an irrational number. So an irrational number cannot be written as a fraction of two integers. And you've probably seen in previous courses, so of course you have rational numbers like 3/4 minus 2. 0.5 is just half, so you can write it in this way. 0, you can write it as 0 over 5, for example, and so on. And you've probably seen also in courses that square root of 2, pi, e are irrational. But today we're going to see how we can actually prove that something like square root of 2 is irrational. And here you can see that proving that it's irrational is sort of making a statement about what it's cannot do. So it's sort of like a state. You need to show that there is no way to write it as a fraction. And that might seem a bit complicated at first. And that's where proof by contradiction is such a powerful tool. So let's do this. So let's prove by contradiction. So first of all, it's always good in the proof to state the technique you're using. So let's start by saying we use proof by contradiction. So we're going to state that we are proving it by contradiction. And so what does that mean? So the proof by contradiction is we assume that what we want to prove is false, and then we need to get to some contradiction. So let's say assume toward contradiction that square root of 2 is rational. Okay, so the good thing here is that this gives us something to work with, because now we can assume that square root of 2 is rational, and so we can make some assumption, and then the idea then is we need to work with that assumption to try to find some contradiction. Okay, so what does this mean? By definition, there exists integers m and n, and I can assume that they will not have any common factors. So let me write this and we'll talk about it. With no common factors, and n different than 0, such that square root of 2 is equal to m divided by n. Okay, so what do I mean by no common factors? I mean, so you can always write 0.5 as 2/4, but then the 2 and the 4 have common factors because you can write it as you can write it as the top as 2 times 1 and the bottom as 2 times 2, and they have 2 as a common factor, so you can cancel that out. And so this is a representation of half with no common factors, and every time you have a rational number, you can cancel out and you'll end up with something with no common factors. So I'm already assuming that the m and n here, we have removed all common factors. Okay, so let's backtrack here. So I want to prove square root of 2 is irrational. And so what I'm going to do is I'm going to assume that it's rational, and I need to find a contradiction. So if it's rational, then I'm able to find m and n with no common factors and n different than 0 integers, such that square root of 2 is equal to m over n. Okay, and of course contradiction is nice because it gives you something to work with, but it doesn't tell you what is the contradiction that you will find. So it's generally a bit harder in terms of creativity of finding out what to do. So for now, what you can do is continue to play with this. So if square root of 2 is equal to m n, if you square on both sides, so squaring both sides, we get that 2 is equal to m squared over n squared, and this implies that m squared is equal to 2n squared. Okay. Now, we saw in the contrapositive video that if the square of a number is even, then the number is even. So go back to that video and take a look at that proof. So we can use that proof now. And so what we have is, thus, m squared is even, since it's 2 times an integer, right? So m squared is 2 times n squared, and n squared is an integer. So m squared is even, implying m is even by a previous theorem. So this was previous theorem. So this was a theorem that we proved with contrapositive. So go and take a look at that. But yeah, so we know that if m squared is even, then m is even. Okay. So if m is even, thus, you can write m as 2 times an integer. So let m equal to 2 times k. So you can write m as 2 times an integer. Then, if you square that, k squared, right, you get m squared. So will be 2n squared, right? So if m is equal to 2k, then m squared, which is 2k squared, will be equal to this here, 2n squared. And that means, if you do some algebra, that 4k squared is equal to 2n squared. And that means that n squared is equal to 2k squared. Oh, but what does that mean? That means that thus, so this implies that n squared is even, right? So n squared is 2 times someone, so this is an integer, so that means that n squared is even. And we already saw that if n squared is even, then also n is even. And thus, n is even. Again, we proved this using the contrapositive. But now you have an issue here, because notice that both m, so let me highlight this here. So m is even and n is even. But we had assumed that m and n have no common factors. And if they are both even, they actually do have a common factor. Because if they're both even, then they have a common factor of 2. And so this contradicts what we said before. So, however, both m and n being even contradicts our assumption that they share no common factors. Therefore, our original assumption is false. So the assumption that square root of 2 is rational has to be false, and thus square root of 2 is irrational. So proving our theorem.